So working our way through the pipeline process, remember this just moved from left to right. One of our final filters that we're going to leverage is called an outbreak filter. We haven't gotten into this in much detail before, but these protect from what we call large-scale virus outbreaks in smaller non-viral attacks such as phishing scams, malware distribution as they occur. What we're using here are heuristics and basically stats that say what's the normal volume of traffic that we see, what's regular. And once we know what regular is, and sometimes this is classified as a histogram, right? You've got this table and it says, this is a normal number of connections that I see, this is a normal number of files, and we've got a threshold where we allow for growth. You know, we go, okay, well today was a busy day, traffic is up 20%. But when it starts to break beyond a certain level, we go, you know what, this is not normal. This looks like it's some type of automated behavior where some type of worm or some type of malware is propagating rapidly. And the idea of this outbreak filter is that we're supposed to look at the traffic. Again, we're measuring a number of different attributes, but if we see something that breaks out of a given threshold that we accept, we'll say, you know what, I think what we're experiencing right now is some type of new attack. And what's cool about this is because it's not signature-based, we're not looking for a dirty word in a file like you would with DLP. We're not looking for a past reputation score necessarily. Like we can leverage it because it's part of the contextual data. You know, okay, this guy has a really bad reputation and here's this flood of traffic. It can be part of the context, but what we're really thinking about here is what is the change in volumes and in behaviors from what we normally see. And again, because this isn't tied to an exact signature, it's more of, again, a behavior that we're trying to watch for. This is our chance to potentially catch something that's 0 day. We could see things that are spreading and maybe a signature or rule hasn't been written yet, but when we see this burst of traffic and we say, hey, here's 1,000 messages going out, we go, wait a second, we haven't seen 1,000 messages go out ever. Typically, it's like a dozen at a time. Why don't we go ahead and delay those to 100 every 5 minutes for the next several minutes? And when you do delays like that, it's really not that strange for your mail server. Let me tell you what I mean by that. The SMTP server has a buffer that it services that says, here's a bunch of email that's waiting to go out. Now, when that mail server wants to deliver the mail, it'll connect to another mail server, right? Well, when you get there, that mail server may be doing all the same things that we are here. The other person could be using ESA, and they could have reputation data on us. And if our reputation data doesn't look great, and we don't typically send them a lot of email, and we flood them, they're going to see that, and they could jump in and start to delay it or start to basically throttle the volume of email that we're receiving. Now, what's going to happen is the email is just going to sit in the buffer of your server. And it's going to try to retransmit, it's going to try to retransmit. And after a given amount of time, it's configurable by the mail administrator, we can tell the user, hey, there's some problems delivering your message here. We're trying to talk to that other server. There's some delays. And this stuff happens. It's good because we can catch new attacks, of course. It's sometimes bad because you can also catch legitimate traffic. There's sometimes just bursts in traffic behavior. Think about Black Friday. Maybe you're not in a retail industry, but think about the volume that retail experiences on that one day, and the fact that they have to maintain a baseline that says this is what normal is. They're like, how many orders did you have on Christmas Day? They're like 3. Like, how many did you have on the day after Christmas? Maybe it was 300. Our sensors, our appliances, they don't know holidays, they don't know when a gold master is being produced or a product is getting ready to ship. So as it tries to apply baselines and the past to the present, really, in terms of identifying traffic flows, you can potentially hit some false positives. Again, just because behavior is not always the same, right? Good stuff to think about. So again, the upside is it gives us some potential 0-hour protection because we're watching for strange behavior. The downside is we're strange creatures. We have abnormal behavior. Sometimes we're working really late, sending tons and tons of emails out late into the evening. Again, the idea is that this shouldn't be so sensitive that it's triggering on legitimate traffic, but we don't want it so, just basically so dumb and so numb to what's happening around it that it can't jump in and get evolved. There's going to be sliding scales that you can leverage to basically tweak the way that we detect these styles of attacks and kind of leverage what they call here the telemetry-based zero-hour virus and malware detection. So when we talk about outbreak filters, there's a lot of different things we can leverage. There's the live reputation filters. These are coming from Senderbase. They're constantly being updated. We've got new and updated signatures. This is the definition of what malware looks like. We've got authored and dynamic rule sets. So who does this traffic apply to, how and why? Cisco's already got rules that they've built that we can modify and adjust. We're constantly getting updated. I've read somewhere between every 3 and 5 minutes, but I'd say just for any type of quizable purposes, or should anybody ask in the future, how often does it update? Every 5 minutes. Compare that to what? We've got, Windows, it gets a big update every, second Tuesday, and then emergency updates the rest of the time. This is a living, breathing threat intelligence device. When we talk about the security filters, the industry's most effective security filters, we're leveraging virus outbreak, anti-spam, email and web reputation, IPS, firewall botnet filtering. Again, think about all the components. We've got all the intelligence of OpenDNS. We've got all the intelligence of Senderbase. We've got all the threat intel feeds from people that are running IPS that are sharing their alerts. Everything we talk about here with web reputation, this is in regards to email, right? Well, we can do this type of stuff with other components. So as other Cisco customers are getting attacked, as they see these con men and these criminals trying to attack their organization, we're taking notes, we're recording it, and we're sharing that with other people that are part of the, basically called the Cisco family. If you've got the equipment that's sharing threat intelligence data with everybody else, you're basically defended against the other types of people that were attacking other Cisco customers. It's highly advantageous. So when we talk about outbreak filters and rules, you've got rules, and the rules could be something like an attachment file type. And then you'd come along and say, well, I'm interested in JPEGs, I'm interested in PNG, I'm interested in executables or zips. We could have file keywords. VBS is typically up to no good, right? Visual Basic. You could be using it for legitimate reasons, but this is just like kind of an old classic way for people with a little bit of skill to become really kind of obnoxious and dangerous. So anytime I've seen VB scripts go by, been a bit suspicious. Other ones I'm suspicious of, CHM. This is compressed HTML files. You can actually download a book in a CHM format. It's kind of like PDF. And you go, oh, that's fine. It's not much different, except there's a lot of capability to deliver malware in CHM. I know there's also in PDF, but we're typically hardened a bit better against it, whereas CHM is kind of a less commonly used format. So you can get away with some cool techniques that a lot of people aren't looking for. So again, from my perspective, not that we're in a goal to spread malware, beat infections, or beat detection. What we're really looking for are what types of things do we want to allow or deny. And again, you have your own experiences, you've got your own environment. Just realize that we can filter for specific things. We can filter by file size, whether or not a document is encrypted, message URLs, as well as antivirus signatures. When we talk about adaptive rules, again, we can look at things like mismatched content types. It said it was a doc, but really, it's an executable. See, you were blocking executables based on the rules we're talking on the previous screen. So somebody tried to send the file through, EXEs are blocked. What would you do? Zip it? Change the file extension to doc, perhaps? Let's say that you change the file extension to doc and you tell the other party to just rename it when it gets there. Well, as it crosses the network, it's pretty cool. There's something called a content type mismatch. The ASA's HTTP inspection engine, as well as the Cisco IPS, this is going back before SourceFire, had the capability to basically trigger on a content type mismatch that was being passed over HTTP. So to articulate what that is, you're basically saying, hey, I want to grab a file, and it's file.doc. Well, as you're downloading that file, at the beginning of every file is a header, kind of like just about anything else that we deal with in networking, right? So you've got this header, and the header lets an application know what to do to render that document appropriately. So for example, let's say that you record a video with your computer and you told the video application to output in QuickTime. So QuickTime was leveraged, it produced an AVI file. Now you go and rename AVI MP4. Totally different codecs. You renamed it MKV. Totally different codec. But when you double click it, the actual header of the file hasn't been changed. You just changed the file name. So that file header is actually what's going to be analyzed by, let's say, your media player, like VLC. And VLC goes, oh, it was called AVI? Great, that's for Windows to associate AVI files to VLC. Once VLC is actually opening the file and trying to show you a movie and create, 7.1 surround sound or whatever, in order to do that, it's got to be able to read and decode the file. There's attributes for it in that header. So some people look within the headers for what they call magic numbers, and it says that file is this type of document. Like that blah.exe is actually a PDF, or blah.pdf is actually an executable. If you've got a Linux-based or Unix-based operating system, OS X should do it as well, you can use the file command just from your terminal and say like file and then point to a file like a PDF, right? And it'll tell you this is a PDF. And you change that PDF to something.exe and you say file something.exe and he's like, that's a PDF. It's because he's using that content header for it. Sorry if I spent too long beating up on that concept, but it is important. It's something that a lot of technologies that we use for security have leveraged over the years to say, something suspicious is happening there. So that's all that we're doing here. Is somebody passing a file, when they pass the file, does the file type match the file extension? Maybe somebody just renamed it being goofy. It was a harmless, activity. Or alternatively, somebody's trying to be tricky and sneak by. A lot of times if I'm trying to secure things, I would watch for this and I would actually drop based on it. But again, give it a whirl, see how it serves you, and I hope it works well. If it doesn't, let me know. I don't want to give you bad advice. We could watch for things like spaces and file names. Maybe we've got a forced naming convention that we make everybody use. If there's multiple extensions, this is where people like to be nasty. Some operating systems will hide this, right? So like if you looked at the I love you virus, you got a file attachment that says I love you.txt. And you go, that doesn't look bad. Who loves me? And they say Visual Basic loves you. There's a VBS extension that Windows wasn't showing you. So you click on it and you go, oh, that's just a text file. Nope, something nasty. It's a virus. This could happen on anything. Realize in today's, unfortunately, day and age, a PDF versus a document file versus an HTML document versus even like an MPEG, if you downloaded a movie, these could all have embedded things like JavaScript inside of them that are being executed when you launch it. A lot of PDF viewers will execute JavaScript that's held inside of that PDF. Same thing with CHM files. So when we see these, we can't just say, oh, that's not malicious. That MPEG could be totally malicious. You could have a PCAP file that has an exploit in it for a vulnerability in Wireshark. So somebody sent you a PCAP, you opened it, and it could explode. I don't want to scare you. I just want to tell you that these other file types could potentially be just as nasty as an executable. So when we're blocking things, we want to kind of look at, okay, I can block on specific file types, and I can also block on, like we said up here, if somebody tries to change that file extension to get by me, I can see that it's been changed, and I can go ahead and stop it. Cool. So looking at outbreak filters, basically when we're looking at content, it's, I think, pretty difficult to say that's absolutely a threat or that's absolutely harmless. I'd even say saying that something is absolutely harmless is even harder, right? So what we tend to do is have this kind of grading scale from 0 to 5. And we say, what is the likelihood that this is something really nasty? 0 is none, 5 is, of course, extreme. Based on this score, we can take different actions. So what we see here is a mail policy. This is where the rubber meets the road. Under the section of outbreak filters is where we can specify parameters that have to deal with outbreak filters. Here we see the processing flow. So things that we're going to leverage, of course, Talos, we're going to leverage our antivirus engines. Again, as traffic comes in, we can leverage Sophos. We can use McAfee as well. And we can also leverage AMP. Again, when we see the verdicts coming in from those antivirus engines and we're considering within a virus outbreak filter, of course, the message passes is through the antivirus because the message didn't match a signature. That can happen, right? All we do is create a hash, look at the hash and go, nope, it's not a known bad guy. That's all that antivirus does. It doesn't tend to like take that file and run it and see what it does. That's what's going to happen from AMP. We may not get a message till later. Of course, when we do, we can make better decisions. The appliance receives what's called Rule V1, raising the threat level for all zip files containing executable parts. The message hits outbreaks filters, and it's going to be quarantined. Now, continuing, later, let's say that time is passing and we have more good information. The message passed through antivirus because it didn't match a signature. We did receive that Rule 1. We raised the threat level, and now Cisco Talos published Rule, and we see just version 2, matching only zip files containing executables that are larger than 36 kilobytes. See how this becomes higher resolution? And then again, more time passes, Cisco Talos publishes Rule 3. Everything that was happening before is the same, but now that we've got a newer rule, we can say, okay, well, specifically, not just larger than 36 kilobytes, but we've narrowed it down. We've seen more pieces of malware, and they all carry this common characteristic. They're all between 50 and 55 kilobytes, and prices in the file name match. This is basically just how signatures work. Somebody says, here's how we catch a bad guy. Here's how I catch a bad piece of traffic. And then you run that for a while and you'll find false positives. And you'll start seeing that you're matching other traffic that's legitimate. So what we do is become more and more specific about what malware is. Our goal is to be extremely specific. But the problem is if you're too specific, you're going to miss other malicious traffic. That's a false negative. So if we're too broad, we get the false positives where we're quarantining or grabbing other traffic that's legitimate. And that's got to be, kind of handled manually by the user. The cool thing about getting these updates from Talos is that we get more and more specific. So of course, we're having less false positives and ideally no false negatives. Finally, Sophos and McAfee catch up, and they've published patterns to catch the virus. If they can, they're going to catch it earlier in the processing pipeline. But again, many times this is the way that it works. You'll see that there's new attacks, there's new threats that are out there on the internet, they're being circulated. Eventually, somebody figures it out and they write a rule, but it takes a while for that rule to get published. A lot of times, like even Talos, they're going to want to test the rule internally, make sure that it's not breaking things. If they publish it, push it out to a bunch of customers, and it does break something legitimate, now people are mad at Cisco because Cisco's rule broke their legitimate traffic. So false positives are something we've got to be really, really careful with, which is why it takes a little bit of time for the vendors to release these signatures. Here we are looking at our outbreak filters, and you see the quarantine names, you see the types, we see some message counters, we see what our policy is here, we see the last message that was quarantined, the size of it, and so forth.